Hey guys, welcome to the channel, and in this video I will be explaining you about one concept in graph, that is the bipartite graph. So first I will explain what the bipartite graph is, and after that with the help of the example I will try to find out whether the following graph is bipartite or not, and after that I will show you how to code this effectively. Okay, so this is a very popular concept in graph, so let's dive into it. Suppose that if we have given this graph which is undirected graph, so we have given this undirected graph and we have to find out that this graph is bipartite or not. So now first I will explain you what the bipartite is. Suppose if we have given some graph and if we divide the graph into two parts such that the nodes in one part does not have the edge directly connected to it. For example, if we place this 1 and 3 node in one part and if we place 2 and 4 in another part, then there is an edge between 1 and 4. Okay, let me draw the edges. There is an edge between 1 and 2. There is an edge between 4 and 3, and that's all. There are these three edges. So as you can see, the nodes in one part does not have the edges connected to it. That means there is no edge between any nodes of the particular part. Likewise, there is no node between there is no edge between the nodes in this particular part. Okay, so this terms as bipartite graph because we divide them into two parts such that there is no edge between any nodes of one part to itself. So let's try to find out how to do this. Okay, so effectively what we are doing, we are using the concept of DFS here. Now see how to use the DFS here and find out whether this graph is bipartite or not. Okay, so from the main function what we are doing is we are calling DFS bipartite graph function, in which we are calling this first node, and along with this first node we are passing a color which represent that if it belongs to one part, then I am saying that it is of red color, and if it belongs to other part, then I will say it's of blue color. So I will just name this as red and blue so that both the parts will be distinguishable. So I will pass red as a color. Okay, now what we need to do is, whenever this function is called on this node number 1, the first thing we need to do is we need to make visited of this node as true because this node is visited, and assign the color which is passed to this function. So I will assign red color to this 1. After that we apply DFS on all of its children, and first we will check whether the children nodes are visited or not. So if it is not visited, then we will call DFS or bipartite graph on node number 2 with the color that is different from its parent or the ancestor. So the ancestor has a color of red, so we will call this with color of blue. So these two node is called. After it is called, the visited of this 2 is true and it has assigned one color blue. So as you can see, there is an edge between 1 and 2, therefore these two can be on different parts. So this is on red part and this 2 is on blue part. After that we call DFS on this 2 and 5 is called. So make visited of 5 as 2 and this has assigned a color of red because the ancestor has a color of blue. After this node 5, we see that there is no node left which is unvisited. So we will backtrack to node number 2. Now 2 will call the node number 6 and make visited of 6 as 2 and assign this the color of red because ancestor already has a color of blue. See, these 5 and 6 is assigned with color red, but it's okay, these two are in the same part because there is no edge in between them. After that we call DFS on this 6 and 7 is called. So make visited of 7 as 2 and it has assigned a color of blue. After that call DFS on 3, make visited of 3s2 and assign this a color of red. But see, as you can see, we are at here where the node has a color of red and 3 has no node left which is unvisited. So we will check that if for each child of this 3, if the node is visited, let's say this 7, first we'll consider this 7, this 7 is visited, then we will check that the color of these two are same or not. So these are different, so it's fine. After that we will check another child of this 3 or another neighbor of this 3, that is 1, that is also visited. So if it is visited, then we will check that color of these two is same or not. So color of these two is same. So here we can see that these 3 and this one cannot be placed in one part. Okay, but this is in the same part. Therefore we found out that in this particular graph there is no way we can form a graph which is bipartite, which divides the nodes into two parts. Therefore this returns false. Okay, because as you can see 3 and 1 lies in the same part. Therefore this is a concept or theoretical concept to solve this problem of bipartite using DFS. Now let's see the time and space complexity for this. The time complexity in this case is O of m plus n, which is equal to the time complexity of the DFS algorithm, because internally we are applying DFS only. And the space complexity is O of n, because we are taking this extra array visited, which will keep track of the nodes which are currently visited or yet to be visited. So this is the time complexity and this is the space complexity for this case. Now let's look out how to solve this question using code. So I have taken the graph in the form of the unordered map, in which I have taken this nodes in the form of adjacency list format. Okay, so what we have the same graph which I have showed you in the example, like I have showed you here also. So this is the graph which I have taken as input in the form of the unordered map, and I showed you how to solve this and find whether this graph is bipartite graph or not. So I will just quickly go through the functions. So here we have the function which we have implemented. Its name is bipartite, and we passed the input as the graph, the visited array, the check, the flag, the start, and the color. Okay, so why I have used this check and this flag and all, I will show you with the help of this code. Initially when we call any node, what we need to do, we need to make a start of that node s2. So I have make visited of start minus 1 s2. So I have take this start minus 1 because we have taken the visited array whose index start from 0, and we have the nodes which starts with numbering of 1. So therefore I have for node number 1 I have make this visited at 0th index. For node number 2 we have make visited at first index, and so on. Therefore we make visited of start minus 1 s2. After that, what we need to do, we need to store the color for each of the node. For that we have taken the start unordered we have taken this start or this check unordered map, in which what we need to do, we need to insert that for particular node what is the color it is assigned to. So it's stored in this start, it's stored in this check variable. Okay, or check unordered map which we have taken. So this stored the color, this shows the visited or not visited, and for each neighbor of the nodes which we are currently at, we will check that if the neighboring node is visited or not. So if the neighbor node is visited, then we will check that the unordered map which we have taken for check, we will check that the color of the neighbor is same as the color of their ancestor or not. So if both has the same color, then we will simply put flag is equal to 0. That means our answer is stored in this flag variable. Okay, otherwise if the neighbor is not visited, then we will check the color of the current node. We'll check that if the current node has a color of red, then we will assign different color blue to its neighbor, or if the current node color has blue, then we will assign color red to its neighbor and call this recursively. So let's see this. When we are at node number 3 in this example, and we will check that visited of its neighbor is true, that is 1, then we will check the unordered map and find out that if check of this one is red or blue, so it's red. Okay, so therefore both has the red, therefore in that case it will follow this first if condition. Okay, otherwise it will follow the second and it will recursively called, and we will find out that whether the graph is a bipartite or not with the help of this flag variable. So as I have explained you that the time complexity in this case is O of m plus n, and the space complexity is O of n, because we have taken an extra array visited of size O of n. Now let's see the working of this code. When we compile this code, it compiled successfully, and when we run it, it returns 0. So 0 returned, that means it is false. Therefore we don't have a graph which can be divided into two parts, so it's not a bipartite graph. Okay, so hope you got this problem. If you find any difficulty in understanding this question, just let me know and I will help you. Thank you.